Hello guys, I hope you are doing extremely well. And today I am going to discuss the problem which is the linked list cycle. Okay, so we have given a linked list and we have to find out the given linked list have loop or not. Okay, the for example, like that. So this is a linked list. So here we will check that is a 3 is the first node and 2 0 4, and it is connected to the encounter again to the 2. So when we will iterate over here from 3 next 2 here, then here and here, again when we will again pointing to the next node which is already visited, it means that loop is presented here. So in this also in this problem, 1 pointing to 2 and 2 again pointing to 1, it means that loop is presented. So 1 here in this example, and 1 is not point out the any other node, so we can say that there is no loop present here, so we will return false. And here loop is present, so we will return the true. Okay, also here we will return true. So this is the problem statement. Yeah, so how to approach this problem? What is the intuition behind this problem? Okay, so first of all, first approach will comes in your mind that brute force, extremely brute force. uh, if I uh, store hashing. Okay, we will use the hashing hash data structure. If I store the node in the hash table in the form of key value pair, okay, and mark the mark the node true. If node is present, if once the node is encountered, it mark true. If and iterate again next one, and if it is the this is the visited, then it is also the mark as true. Okay, when node is visited, then we will mark the node as a true. Okay, again and again. If if the when we will again move on to this node, and node is already marked as a true, it means that node is visited, or we will return true. Here also we are using the same concept, which is the hashing. Okay, but now let's talk about the coding part, then we will discuss the extremely better approach. Okay, so this is the coding part here. First of all, we will take a pointer which is the current, and we will take an ordered map. An ordered map which is the store the value. Map is the data structure which store the value into the key in the form of key value pair. And first one is the node, second one is mark as bool. Bool it mark as true or false, it totally depends on you. Then we will iterate over here using the while loop. While current is not equal to null, while current is not equal to null, we will check that over here. If mp dot find current is not equal to mp dot end, okay, this means the condition is uh, the current node is visited in the unordered map. If in the form of the map, it means some nodes has been encountered before indicating, and hence we can say that the loop is presented here. Okay, because it says that if we are not reach on the end of the map, and node is presented again, we are encounter the node again and again, then we can say that the node is present, loop is present in that given linked list, and we will return true. Else we will move on to the next iteration, and current node, if node is visited, we will mark as true, and then we will move on to the current equal to current next. If 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 loop is not present over the this iteration, then we will simply return the false. Okay, so this is the brute force, and this is the brute force approach, and which is taking the time complexity of Vigo of n and space complexity of uh, what, 1 or n. Yeah, n, because hashing data structure takes the Vigo of n space complexity. Okay, so time complexity wise, if I'm talk about the time complexity wise, it is good, but space complexity wise it is not good, because big one is the auxiliary space. Okay, so reduce the space complexity from big of n to minimum time space complexity, they will use the another approach. Okay, yeah, so we will talk about the another approach, which is the fluid cycle detection algorithm, which is the algorithm which is the based on two pointer. Okay, like we will iterate over here, we will take a pointer slow and fast, slow and fast here, both are presenting on the head of the linked list, and slow move on one step and fast move on two step. After iterating these conditions, we will check a condition. If slow equal to fast, it means that loop is present over here and return true, else return false. Okay, now let's iterate. Slow is here and fast is here, uh, while fast or fast next is not equal to null. Okay, now let's move on. Fast move on to the fast next. Fast is here and slow equal to slow next. Okay, slow now here. Yeah, now we will check fast is not equal to null and fast next is not equal to null. Yeah, condition is true. Now we will again iterate over here using the two steps. Slow, slow equal to slow next. Slow is now here and fast is now here, because fast take a 2 point, which is the 1, and second is 2. 1 is 4, because fast is here, but we will forward two steps. So first step it pointing here, in second step it will pointing here, but slow is here, so slow move on to the here. Now slow is here. Yeah, we will check if slow equal to fast, the condition is true or not. No, condition is not true. What we will do here again, slow equal to slow next. Slow next means that it is move on to the one steps, which is pointing here, and fast moving two steps. Okay, it is remove here and fast one step here and second step here. Okay, okay, slow and fast pointing at the same node, so we will check that condition over here. If slow equal to fast, return true. Okay, so condition is true, so simply return true. Also we will start here and fast here. Slow equal to slow next. Okay, slow pointing here to here, and fast equal to fast next. Now fast is here, again pointing here. Okay, now We will check that condition over here, slow equal to fast. No. Okay, slow equal to slow next here, and fast equal to fast next. Fast equal to fast next here. Oh sorry, this is slow. So it means that loop is present because slow and fast both are presenting at same node, because both are pointed to the same node, so we can return true. Here loop is not present because slow is here and fast is here. Initially we will not count here because fast is next is not equal to null. Fast we will, because first condition we will check while fast is not equal to null on a not equal to null, and fast next is not equal to null. In this case both conditions are false, so we will return false. Condition are not matched. Yeah, so this is it. This is it. Uh, we will now, let us move on to the coding part, and this is very simple. Yeah, so this is the coding part here. We will take a two pointer, which is the silo. Firstly, both pointer is starting the same node here, and slow and fast both presenting at the same node. Then we will check that condition fast and fast next is not equal to null. Here we are talk about the this this condition. In the third example we will discuss the this this condition fast next is not equal to null and fast is not equal to null. Okay, because both conditions are false here, so we will move on to the directly as written false. Okay, but here we will iterate over here silo equal to silo next, because silo pointing take a one steps and fast take a two steps here and here. So whenever, if I equal to sorry, if silo equal to fast, it means that loop is presenting in the given linked list, and we will simply return the true. Okay, so these approaches, this is algorithm which is called the fluid cycle detection algorithm. Okay, which is the very famous algorithm which is solve the problem in the big O of n time complexity and big O of one, big O of one space complex, which is the much better than the map which we are using in the previous code, which is the map data structure. This is the quite simple and good rather than map data structure. Yeah, so this is it from my side, and if you are uh, like the video, then subscribe to the channel. Okay, so thank you.